Welcome to the DIY Honda Garage channel. This presentation covers the diagnostic trouble code P0571, specifically related to the brake pedal position switch circuit malfunction in the Honda Fit model years 2015 to 2020. The brake pedal position switch plays a critical role in signaling the status of the brake pedal to the vehicle's electronic systems, including the engine control module, ECM, and the anti-lock brake system, ABS. When the brake pedal is pressed, this switch should close a circuit, thereby illuminating the brake lights and enabling other systems that depend on the brake signal. If the switch malfunctions, it may lead to various issues, including unexpected acceleration or failure of brake lights to function properly, both of which can pose serious safety risks. Diagnosing this error involves a systematic approach to identify either the switch itself or the related wiring and components as the source of the malfunction. Understanding how to check these components is vital in ensuring the safety and reliability of the vehicle. The DTC P0571 refers to a malfunction in the brake pedal position switch circuit. This component is essential for the proper functioning of various systems in the vehicle, including the brake lights, which signal other drivers of deceleration or stopping. Located adjacent to the brake pedal, it detects the position of the pedal and sends corresponding signals to the powertrain control module, PCM. When the switch is pressed, it completes an electrical circuit, signaling that brake lights should be activated. Conversely, when the pedal is released, the circuit opens, indicating that the vehicle is no longer braking. If this switch fails, it can result in brake lights that either stay illuminated or do not activate at all, complicating driving conditions and potentially leading to safety hazards. Identifying possible causes for DTC P0571 is critical to effective troubleshooting. One primary suspect is the brake pedal position switch itself, which may be defective and unable to signal correctly to the systems that rely on it. Wiring issues might also be at fault. For instance, a short or an open circuit can disrupt the signals traveling between the switch and the PCM. Furthermore, a faulty PCM can contribute to this DTC being set, especially if the module is not processing signals correctly. It is essential to methodically rule out each of these causes during the diagnostic process. Each potential issue requires a different approach to troubleshooting, emphasizing the need for meticulous checks of both the electrical components and related circuitry. Symptoms linked to DTC P0571 can severely impact driving safety. A common indicator is the malfunctioning of the brake lights. They may either not illuminate when needed or remain on continuously. This can confuse other drivers, increasing the risk of accidents. Moreover, if the brake pedal position switch fails to communicate with the PCM, the vehicle may display unexpected acceleration, allowing the vehicle to potentially move even when the driver expects it to be at a standstill. Drivers may also notice a warning light on the dashboard, indicating a fault in the braking system. Awareness of these symptoms can prompt timely diagnostics, preventing serious safety issues before they escalate. The first troubleshooting step for DTC P0571 involves checking the brake lights without pressing the brake pedal. This basic test helps determine if there is an issue unrelated to the brake pedal's engagement. The presence of illuminated brake lights when the pedal is not pressed indicates a potential short circuit in the system. If the brake lights do stay on, proceed to step 9. However, if they are off as expected, this suggests that the circuit should be functioning correctly at this stage, and you will move on to step 2. This initial check is crucial as it provides valuable insight into the overall health of the braking system's electrical components. In this second troubleshooting step for DTC P0571, You will check the brake lights again, but this time with the brake pedal pressed. This action tests whether the brake pedal position switch is functioning properly when engaged. Upon pressing the brake pedal, the lights should illuminate if the circuit is intact and the switch is operating correctly. If the brake lights come on, it suggests that the switch is functioning adequately and we can continue to the next step. However, if the brake lights do not illuminate, this indicates a failure somewhere in the system, necessitating further investigation in Step 5. This step is key to isolating whether the fault lies within the switch or in the relay of the brake light signal. Step 3 instructs you to verify the brake pedal position switch signal using a Honda Diagnostic System, HDS. Turn the vehicle to the on mode and observe whether the signal transitions from on to off as the brake pedal is pressed and released. If the signal behaves as expected, it suggests an intermittent failure. Hence, checking for poor connections at both the brake pedal switch and the PCM becomes essential. Alternately, if the signal does not change at all, it points toward a more serious malfunction requiring further investigation as outlined in Step 4. Monitoring the switch signal is pivotal, as it ensures not only the correct function of the switch, but also verifies communication with the vehicle's electronic systems. In this fourth step of troubleshooting DTC P0571, you will conduct an open wire check specifically for the stop LT line. Begin by disconnecting the PCM connector A and measuring voltage between designated test points while the vehicle is in the off mode. Battery voltage should be present if the stop LT wire is functioning correctly. If battery voltage is detected at the test points, it confirms that this wire is intact, and the issue may lie within the software of the PCM, necessitating an update or substitution. However, if no voltage is found, it indicates an open circuit between the PCM and the brake pedal position switch. Thus, repairs must be initiated on the wiring. Proper assessment of this wiring connection is crucial, as it directly influences the operation of the brake signal system. Step 5 involves testing the brake pedal position switch directly to ascertain its functionality. This test evaluates whether the switch is operating as intended when pressed. A normal switch will complete the circuit when engaged, and if it fails this test, replacement is necessary. If the switch exhibits no defects, you may proceed to the next step. This evaluation is critical. If the switch does not provide an accurate signal to the braking systems, it could lead to a variety of performance issues, including erratic braking responses or complete loss of brake light functionality, which may endanger driver safety. In Step 6, the focus shifts to inspecting fuse number B6, rated at 10 amps, located in the underhood fuse relay box. This fuse is responsible for safeguarding various electronic components, including those associated with the brake pedal position switch circuit. A burnt fuse can interrupt the circuit, leading to multiple symptoms, including the DTC P0571. If the fuse is found to be defective, replacing it is essential. Furthermore, it is prudent to investigate the circuit for potential shorts to ground that could have caused the fuse to blow. This preventive action ensures that once the new fuse is installed, the risk of recurrence due to an undetected fault is minimized, thereby ensuring the reliability of the system. Step 7 requires measuring the voltage between two specified test points while ensuring that the vehicle is in the off mode. This test checks the continuity of the +B stop wire, which should carry battery voltage from fuse B6 directly to the brake pedal position switch. If battery voltage is confirmed, it indicates that this section of the circuit is functioning correctly. In the absence of voltage, it highlights an open circuit, necessitating repairs on the +B stop wire to restore connectivity. Accurately diagnosing and fixing wiring issues is crucial, as it directly impacts the functionality of the brake light signaling system. In Step 8, a second open wire check for the stop LT line is performed, similar to the previous checks. Again, you will require the HDS and PCM connector A to disconnect while the vehicle remains in the off mode. This step ensures thorough diagnosis of the wiring integrity. As in prior tests, the goal is to measure and confirm battery voltage at designated points. Successful voltage readings would indicate that the stop LT wire is operational. Step proceeding involves checking or updating the PCM if necessary. Conversely, a lack of voltage confirms further needs to repair or check for issues in the wiring path between the switch and the PCM. By validating wiring health, you establish a firm foundation for reliable braking system operation. Step 9 is a practical check of the brake pedal position switch and its installation. By observing the brake lights while the brake pedal position switch is still connected, you can assess whether the lights turn off when the switch rod is pressed. This to ensure it is correctly positioned and securely attached. Should the brake lights indeed turn off as expected, the switch is functioning and may simply need readjustment. However, if the lights do not extinguish, it indicates a potential installation issue or malfunction of the switch itself, necessitating further inspection or replacement. Conducting this check ensures that the switch not only works, but is also correctly aligned for optimal performance. In the final troubleshooting step, the brake pedal position switch undergoes a definitive test. Given any previous indications of malfunction, this check serves as a conclusive evaluation of the switch's integrity. If the switch is found to be operational, it points to a short to power in the stop LT wire as the underlying culprit. If the switch is defective, replacement is necessary to restore the proper function of the brake light signaling circuit. Conclusively validating the switch's performance is essential in ensuring the entire braking system communicates effectively, thereby maintaining driver safety and proper vehicle functioning. Final repair verification is a critical part of the troubleshooting process for DTC P0571. After completing all necessary repairs, it is vital to confirm that the diagnostic trouble code has been successfully cleared from the system. Utilizing the HDS, verify that the DTC does not reappear, ensuring that the previous issues have been fully resolved. Additionally, it's essential to conduct a system performance check. This involves taking the vehicle for a test drive to monitor the brake lights and ensure they operate correctly under various conditions. Performing these steps solidifies that the issues have not only been identified, but rectified, assuring the vehicle's braking system functions safely and reliably. Preventive maintenance plays an integral role in avoiding issues like DTC P0571 in the future. Regular inspections of the brake pedal position switch and its wiring connections can preemptively address any wear or potential failure. Ensuring that the wiring remains intact without frays, shorts, or corrosion is pivotal in maintaining reliable operations. Moreover, monitoring and cleaning electrical contacts can also enhance performance and reduce the risk of issues. By establishing a routine checkup schedule, it helps ensure safety and continuous reliability of the brake light signaling system, ultimately contributing to smoother operation and improved driver responsiveness. In conclusion, understanding and effectively addressing DTC P0571 is essential for maintaining vehicle safety and performance. The brake pedal position switch circuit malfunction can lead to significant hazards if left unresolved. Hence, the importance of thorough diagnostics cannot be overstated. By following methodical troubleshooting steps, one can identify and resolve issues with accuracy, ensuring that the braking system functions as intended. Lastly, commitment to regular preventive maintenance helps forestall issues from arising, ultimately contributing to the longevity and reliability of the braking system. Regular checks, diagnostics, and prompt repairs will enhance the vehicle's operational safety and driver confidence. Please like and subscribe to the channel. See you next time!